So now we're looking at ionic compounds. All right, I'm going to go slow, but I want to make sure that stop it at any time, rewind, practice. I want to make sure that you guys got this down, okay? This is the basis for the rest of the chemistry unit, so you need to understand this, okay? So we're going to look at ionic compounds, all right? So a compound, so recall, are, so I won't do this. This is the only thing you have to write down that you have to copy from me. They are pure substances. Remember, we just talked about this. So our pure substances were elements and compounds. And the compound was the pure substances that contain more than one type. Contain more, sorry, this is terrible writing. More than one, I'm going to go slow so you can see it. One type of element that are bonded together in a fixed ratio. We'll go with that, fixed ratio. So for an example, I'll do an example here, even though this is not an ionic. Oh, you know what? No, it's okay. I'll do water because it's one that you recognize. Okay, it's a fixed ratio, 2 hydrogen for every oxygen. This is not an ionic compound, but it is a type of compound. So, ionic compounds. All right. This is a compound consisting of negatively, so we talked about our ions, so negatively and positively charged ions held together by an ionic bond. Okay? Ionic bond is the force of attraction. Okay? Opposites attract here. So that means the positive and the negative ions, because we talked about both, will attract each other. Okay, so ionic compounds. These are properties of ionic compounds, and we are going to do a lab tomorrow that looks at them. Okay, so some properties of ionic compounds. Solids at room temperature. They are hard and brittle. High melting and boiling points, okay? So that means that they are hard and it takes very, very, very high temperatures to melt them or boil them, okay? They conduct electricity when melted or when dissolved in water. So these are all going to be things that we look at tomorrow in our lab. And then many are soluble in water. Not all of them, but many, okay? Not all. So rules for writing formula. I don't know who wrote this sheet, but that shouldn't be there. Formula. So the metal, the cation, right? That's the positive, is written first. Then the non-metal anion, which is the negative, is written second. So I'm going to write that in here. So this is positive. This is negative. And I don't think your sheet's the exact same as mine, but that's okay. The compound form must be neutral. So it will be your positive and negative charges come together and they balance, and then it's a neutral. So our ionic compounds, there's no charge at the end of them when they come together. Subscripts are used to indicate the number of ions of each element. We just talked about subscripts, right? They're attached to the element there to balance the compound. So if only one is required, you can leave out that subscript. So we talked about that. We do not write ones, okay? Use the crisscross method to balance charges. I'll show you the crisscross method, but I want you to understand what it means. I don't want you just to rely on it the whole time. Some metals are multivalent, and I will talk about that as well, okay? Now, so what happens? We talked about ions, okay? We talked about how elements, neutral atoms, okay? So they're neutral because they have the same amount of positives and negatives. So what happens is they want that full outer shell, right? We talked about this, and they will give it away, okay? and then they become ions. All right, so lithium forms a positive 1 ion. Why? Because lithium gives up its electron, because it has 1 electron in the outermost shell, right? So lithium is 3. I believe lithium's number is 3. Yeah, it's got 4 neutrons. Yeah, all right. So lithium is 3, right? So it has 2 in that first shell, it has 1 in that second shell. So it gets rid of that 1. So now it has 2 electrons and 3 protons. So this is where the lithium plus 1 comes from, okay? Oxygen, right? We talked about oxygen. Oxygen has 6 electrons in its outermost shell. So oxygen will go and it will take 2 electrons to fill that outermost shell. And now it has 2 extra electrons, so now it's -2 charge, okay? So the ionic bond is the opposites attracting. So this guy's positive, lithium's positive, oxygen's negative. They will attract each other, they will come together, and they will form a compound. Now, I'm just going to, I'm over here. I'm going to just shoot paper here. Like, I love the crisscross method, but I don't love it because I think kids become a little too reliant on it. But I want you guys to understand what it means. So I'm going to use Lewis dot because when we get to molecular compounds, this is what you have to do. So I'm just going to use Lewis dot for example. So I'm going to do, I'm going to do the full thing. Oxygen, it has 2 in its first shell, right? Protons. Oxygen is 8, right? So 2 and 6, I'm just trying to remember. So now it's neutral. This is our oxygen atom. So it gets 2, I'll do the Lewis dot diagram. So we have our oxygen, and we have 6, because that's how many it has in this outermost shell. Okay? So this is Lewis dot, this is the Bohr-Rutherford. So what happens with oxygen is that it needs 2 electrons here to fill that last shell, right? It needs 2 electrons to fill that last shell. So 2 electrons come over. Okay? All right, and now it is full and it is happy. Okay? So what is happening is we have lithium here with 1 electron and lithium here with 1 electron. Remember? So lithium has 3 protons. It has 2 in the first shell, it's 1 in the second shell. So it's going to get rid of that one, right? So it wants to get rid of this one. So what is lithium going to do? Lithium is going to go and it's going to be like, hey, oxygen, you can have my electron because I don't want it. Now I have this full first shell and I'm happy because that shell is full. All right, but now he's just now positively charged. This lithium comes over. It has an electron as well that it wants to get rid of. So it's going to be like, well, you still need 1 more electron, oxygen. So I'm going to give you my electron. And now I'm positively charged. And this one is negatively charged. And now they're attracted to each other. So they come together and they form a bond. Okay? So we had our +1, our +1, and our -2. But these 2 +1s cancel out that -2. So now it is a neutral compound, all right? So what this tells me, okay, so what we're seeing here is that we have 2 lithium for 1 oxygen, all right? So we have 2 lithium for 1 oxygen. So this is where the compound name comes from, with 2 lithium for 1 oxygen. This is drawing it all out. You do not have to do this for every single thing, okay? And I want you to understand that. The crisscross method might be quite easy for a lot of you. If you're able and you've already went and practiced and you now know how to find their ions, but it's this. You don't have to write the ones, but for the compound, it's fine. So lithium is a +1 charge. Oxygen is a -2 charge. The crisscross method is just taking those charges and bringing them down from superscript to subscript. So that 2 now comes here, and that 1 now goes here. But we don't write 1s. Okay, we just leave it. The problem I have with this is that kids tend to bring the charges down too. Don't do that. The charges don't come down because all of a sudden, this is all balanced now. Like I showed you up here, the positives balance out those 2 negatives. So it's now a neutral compound. So there's no charges in this ionic compound. All right? They're charges when they have gained and lost their electrons, and then they become attracted to each other. They come together, they form that compound, and now it's neutral. There is no charges. Okay? Okay. So you're going to go through and you're going to continue to do this. You're going to first find their ions, okay? I like that this idea has it written out because then you can see for yourself how many of a certain atom or ion is going to form a compound with another ion. If it helps, in this corner here, after you've drawn them all out, all the ions out, you can go ahead and do the crisscross method if you feel like that method's going to be what works for you. Okay, and then you get your answer over here. So you're going to continue and you're going to do the back of that, and then we're going to take that up. After this, all right, we're going to do the naming for ionic compounds. And the sheet's not here, but that's okay. For ionic compounds, it's quite simple, okay? What we have here is the only rule that we do is that second non-metal, right? We always write the metals first and then the non-metals second. And the rule of thumb is we do that because you always write what's on the periodic table first. So these guys are all on the left side. These guys are all on the right. So rule of thumb is you put the element down first that is first on the periodic table, which is these guys. So your metals. You're always putting your metals first, your non-metals second. And even repeat that in your head because I want it to stick in your head that ionic compounds are a metal and a non-metal. Okay? These are the ones that are coming together after they have a charge. So ionic compounds, we're dealing with charges. We have our positive ions, our negative ions, and then they come together to create our ionic compound. And now once they've created the ionic compound, it is neutral because the charges cancel each other out. But I'm just going to give you an example for this one. So we have our lithium, okay, that have come together with our oxygen. All right, so we had our lithium ion and our oxygen ion, but when they've come together now to create our ionic compound, the name, these ones are easy. The name is, you write the metal as is. We do not change the name of the metal. So lithium stays as lithium. But on the non-metal side, you're going to add id on the end. So lithium, or ide on the end, lithium oxide. Okay? So all we're doing is adding IDE to the end of the non-metal. That is how we name them. Okay, so the last rule with these guys, with the ionic compounds, the last little throw a wrench into your plans here, is those transition metals. So those ones in the middle of the periodic table. And I'm just going to pull out my periodic table here so I can talk about them, is these guys here, okay? So all the transition metals that are kind of in the middle from number 3 here, so group 3 to group 12, the deal with them is that a lot of them can form 2 different ions. Some of them can form 3 different ions, okay? So we have to, in the name, and there's an example here because you're going to have to do it here. So you'll see here, copper forms 2 different ions. It can be a +1 or it can be a +2. So that's why we've put in Roman numerals here to tell you what ionic charge this one's going to have. So this guy's going to have a +1 charge. This guy's going to have a +2. Same with the example here for iron. It can be a +2 or it can be a +3. Okay, so in the Roman numeral is given here is a 2. Okay, so it's telling you. So these ones are easy because it tells you the charge of it. All all right? So it's already, you don't even have to look or try to figure out what the charge of this iron is. You already know. This one's easy. It's telling you it's a +2, okay? But when you have to reverse, all right, and you're given a compound and you have to tell me what the name of the compound is, you're going to have to include the Roman numeral so that I know which ion we were dealing with when it came to iron. Okay, so for an example, we will do iron sulfide. Okay, here's iron, here's sulfur. Now, I could leave it like that. It could be two different ways. I could leave it like that, and you would have to then tell me which Roman numeral would you have to do when you wrote out the name for this one. Okay, so we know that it's iron and sulfide, which can be spelled two different ways, PH or F, it doesn't matter. But you have to include the Roman numeral when you're naming it, because you have to tell me which ion we were using. But in this case, there's no numbers here. There's no subscripts telling you how many there is. The rule is, if the numbers, the subscripts are the same for the two, we don't have to write them. Like I said before, chemists are lazy. You know, they don't like to write their ones, and they find other ways where they don't have to write things down. This is one of those ways. Okay? If the numbers are the same, the subscripts the same, you don't have to write them. So what is then the subscript that we have to use for iron? What is the Roman numeral that we need to put in? Well, in this case, we know that iron doesn't have an option of 1, right? Iron is only a +2 or a +3. So we have to go and look at what sulfur is. You have to find out what the ionic charge for sulfur was. If you did that, then you would know that the ionic charge for sulfur is a -2. All right? So because they're both canceled out, and we know that they'll only be canceled out if they're the same, then that means that the iron would have been the +2. So when you're writing out the name for iron, you'd have to do the Roman numeral 2. So the practice sheets for today are, you're going to start with this one, the very basic one, figuring out what the ions are for them, and then bringing them together. Using the crisscross method, fine, and just writing out the compound. Okay? Then the next sheet that you have, and I don't have it on me, but I know which one it is you're then going to be given a compound, and you have to write out the name. Okay? Knowing that the metal names stay the same. The only thing you have to do for that one is just change the ending of the nonmetals to IDE. Okay, that's it. So that's the two parts then. The last part is giving you a bunch of chemical formulas, right? This is what a chemical formula is, remember? And you now have to write the name for it, or it's going to give you a name of a chemical formula, and you're now going to have to write out. So this is a chemical name, so now you're going to have to write out the chemical formula for it. All right? And I am available for questions throughout the day for these ones. But I do want you to attempt, and we will take them up tomorrow, but I do want you to make sure that you're attempting to try to do a couple before you ask me. Okay? So attempt to do some, and then if you still feel like you're struggling, then check in with me and we can do a couple practice ones together until you feel confident with it. Okay? So you need to practice being able to do the chemical formula for an ionic compound. And remember, it's always going to be a metal and a nonmetal, but then also practice doing your chemical names for them as well. And the tricky one is, and just so you know, as I tell my class always, is always check. If you're unsure, always check to find out if it's a multivalent metal. Okay, so a lot of those ones in the transition metals in the middle, you know, these guys here, these are your transition metals, and a lot of them are multivalent. Not all of them, but a lot of them are. Okay, so before you go and write their names out, check to see if they're multivalent, because you won't get a full mark for it if you don't include the Roman numeral for the ones that are multivalent. Okay, but also with that being said, is as soon as I bring the Roman numerals in, kids tend to throw them on everything. Okay, they are only to be used for a metal that has 2 valence charges, because all this needs to make sure is it's construing the information that this metal can be 2 different ionic charges, and this is the charge for this compound this metal has. All right, so we're now not going and throwing Roman numerals on all of them, only for the metals that are multivalent. Okay, so you do have to go back and check your periodic table for that. Okay, that is something that you will have to do. And it will tell you the 2 charges in the top right corner for it on your periodic table. It will tell you what 2 charges it can be. So you have the worksheet that goes along with it. So work through them, ask me questions if you need to, and then we will take this up tomorrow. Okay?